Fall 2014 practice final. Number one, I'm assuming you need some help with. It's kind of weird. So it says x squared over x minus 30 is less than or equal to 0. So what if this just said equal to 0? When does a fraction equal 0? So if I have some fraction equals 0, when the top is 0 and the bottom isn't, right? If the top equals 0 and the bottom equals 0, then we don't really know what that is. And the truth is, that could be infinity or 1 or 0. It just depends. You need calculus to figure that out. So what we want to know is, when does the top equal 0? Well, that's pretty easy. When does the top equal 0? When x equals 0. Okay? So I know that the equal to happens at x equals 0. Okay? Well, and there will be one of these on your final. We can pretty much guarantee it. When is a function less than or equal to 0? When is a function less than or equal to 0? Graphically. No, oh, not the left, not the right. Under the x-axis, right? So if my function looked like this, and right now we don't know what it looks like. Well, you don't know what it looks like. Okay, when is that graph less than or equal to 0? Right here. Does that make sense? Okay, if I had a different function, when is that function less than or equal to 0? Would be this piece and this piece. Does that make sense? Okay. So what I need to know is, when is this graph less than 0? The graph. Well, I'm going to plug that into my graph function and make sure the bottom is in parentheses, x minus 30. And then I'm just going to look at the table for a second to see what's going on. So when x is negative, what do you know about the y values? Notice about the y values. They're negative. Okay? So when x equals 0, we notice that it hits the x-axis. We already knew that because I said when x equals 0, the graph is equal to 0. Okay? And then if I go down, you notice that the negatives are getting further away from 0 until eventually we're almost there. Now they're getting really big. Uh-oh, error. Why do I have an error at x equals 30? A domain restriction. So if we look here, I know that x is not allowed to be 30 because then the bottom is 0. What happens after that? I have these positive numbers, and the further I go down, it's going to take a minute. And eventually, it's getting smaller and smaller. Okay. Well, so I know a couple things. First off, I know the graph hits the origin, and I know over here at 30, there is a horizontal or a vertical asymptote, right? Does this have an HA? How do we tell? When is it 0? When is the HA 0? When the bottom is bigger than the top. Is that the case here? No. So it's not 0. What happens when the bottom and the top are the same power? So if I had like 3x to the 5th over 5x to the 5th, cancel, and the HA is 3 over 5. But in this case, I have an x squared over an x, which means the asymptote is slanted, and the slant is x, so I kind of have this. So the graph looks like this. Okay. Well, they're specifically trying to prevent you from graphing it by putting in that 30, because when you push graph, oh, that's not going to work. Let's do zoom standard. Maybe. So there's part of the graph, but we're missing the other part. So I'm going to go window, and I'm going to go out to, let's say, 40, and then I graph. And I can see part of it, but not the other part. So I need to do zoom fit, which is 0. And eventually that's going to curve back up. It just takes a while. Okay, now, all this is really hard, right? Well, here's another way to solve this. If I look at the zeros and the domain restrictions, so here's a number line. If I were to pick all of the zeros and all of the domain restrictions, I can figure out if the graph is going to be positive or negative at that point. So I know that x equals 0 is an x-intercept. I also know that x equals 30 is an important part of the graph because that's where it's undefined. So all I need to do is figure out those are the only places where something crazy is going to happen with the graph. So I just need to know, is that part of the graph positive or negative? So I'm going to plug in a number. What is a number in that piece of the graph that's easy to use? What's a number over here that's easy to use? -1, or -10, or -100, or -8.73. Okay, so I'm going to plug -1 into the graph. And this is probably how I would solve it. So -1 squared is 1, and -1 minus 30 is -31. So I have -1 over negative, nope, sorry, 1 over -31. What does that tell me? All I care about is positive or negative. It's negative. So this piece of the graph is under the x-axis. And there's no way it can be above the x-axis. Why? Because it would have to hit the x-axis somewhere to switch from negative to positive. Okay, so basically what I'm doing is this. I am going to pretend to graph without actually graphing. So I know 0 is an important number, and I know that 30 is an important number. Excuse me. So the graph could be here, or it could be here. It can't be both. Because in order to switch from blue to green, I have to hit the x-axis somewhere. Or the other way to switch sides is to have some sort of domain restriction, a hole or a vertical asymptote. Okay? Also, I need to look at this section and this section. And I need to look at this section and this section. Okay? So my equation is x squared over x minus 30. So I need to try one of these numbers. As long as it's smaller than 0, it will work. Does that make sense? So I basically have to test 3 pieces. I have to test the smaller than 0 piece, the 0 to 30 piece, and the 30 or bigger piece. Now, if you want to graph it on your calculator and find the window to make it work, that's okay. That works too. On these multiple choice questions, it doesn't matter how you solve it as long as you can figure out the answer. So I'm going to plug in x equals -1, which gives me 1 over -30, which is right here. That point landed in the blue window, which means all of the other points that are smaller than 0 will also land in the blue window. Does anybody not understand that? We okay with that? So this gets thrown away, and this is where the graph is. I don't know what it looks like. Well, we do, but we know it's less than 0. Now, let's test these other 2 windows. What number should I plug in? 10 would work. What else? 1 would work. 8, 7.5. Anything that's between 0 or 30, but let's pick something easy. Let's choose 1. So I'm going to plug in x equals 1. Okay, and that gives me 1 over -29. So if I graph that, 1 and 1 over -29 is right there. What does that mean? Between x equals 0 and x equals 30, what do we know about the graph? It's below the x-axis, right? So this is where the graph is, and this is where the graph is not. Is there any way between 0 and 30 for the graph to cross from the negative to the positive? No. The only way it can cross is it either hits the x-axis, it has a hole, or a vertical asymptote, and it doesn't have any of those. Okay, so now we need to test the last window. What should we plug in? How are we going to test this? 31, okay. So 31 squared over 31 minus 30 is 1. Do I care what the answer is? No, all I care about is that it is positive. So this is where the graph is, and that gets thrown away. Okay. So now the original equation says, when is x squared over x minus 30 less than or equal to 0? What's the interval? -infinity to the 0 count? Yes. So because it's equal to, this is a yes. So it's going to be from -infinity until 30. Parenthesis, what goes on the right side? A parenthesis, because 30 is not part of the solution. If we plug in 30, we don't get an answer. We get error. Okay? What if it would have said this? What would the answer be? So it's going to be 30 to infinity. 30 gets... Can you plug 30 into the equation? No, because you get undefined. So, but is that everything? Is there any other place where the graph is greater or equal than 0 to 0? That's 0. So we need to union this with the number 0. Right? Okay, we'll get a lot more practice with these. I think every practice test has one. So they're not all going to be that long. Some of them, most of them are much easier. But you've never seen these before. Yes? For which one? Uh, yes, yeah. The answer to the original is negative infinity to 30. What if, okay, let's see if you guys understand this. What if it said less than 0? What would it be? Negative infinity to 0, union with 0 to infinity. Or 0 to 30, sorry. Okay. Number 2, do you need help with that? When do we have domain restrictions? There are only 2 ways to restrict the domain. Denominator equals 0, or square rooting a negative. Do we need to worry about square rooting a negative? No, there are no square roots. So if I have x over x squared minus 7, I know that x squared minus 7 is not allowed to be 0. So I add 7, x squared equals 7, take the square root, and I get x equals plus or minus the square root of 7. So the domain would be all real numbers, but x is not allowed to be plus or minus 7, or root 7. So which one of those demonstrates that? It's going to be A. So from negative infinity to negative root 7, negative root 7 to root 7, and root 7 to infinity. Now, if I were writing it, I wouldn't do it the long way. I would just write what I wrote there. But apparently they're not going to do that. Okay, number 3, any questions? So, whenever you are solving a square root equation or a logarithm equation, you always have to plug your answers back in to see whether or not they work. Okay. Now, what if I had this? Does that have a solution? Probably. Yeah, unless something really crazy happens. Can a square root equal 8? Yes. What if I did this? Can a square root equal negative 8? No. So even when you solve it, you're going to get a number, but when you plug that number back in, it's not going to work. Okay? Can this happen? Yes, as long as x is or positive or 0. So we just say as long as x is not negative. But if x is negative, then there's no solution. Okay, how do we get rid of a square root? Square, this cancels that, and then I have 2x squared minus 5 equals x squared. You see an x squared, what should you think? Quadratic. Subtract x squared, and I get x squared minus 5 equals 0. Which one? So I'm going to add 5. X squared equals 5. Take the square root, and I get x is equal to plus or minus root 5. Is that okay? The answer can't be negative, so it's positive root 5. Now let me show you why. Let's plug them in. What is the square root of 5 squared? 5. and then 2 times 5 is 10, and 10 minus 5 is 5. Does the square root of 5 equal the square root of 5? Yes. So the positive version worked. Let's try the negative version. What is negative root 5 times negative root 5? 5. 2 times 5 is 10. 10 minus 5 is 5. Is the square root of 5 equal to the negative square root of 5? No. So the negative version doesn't work. So the answer is A. So what you need to remember is whenever you have variables inside a square root or excuse me, or in a logarithm, you always have to test your solutions. You might get a solution that doesn't end up working. Okay. 4. Any trouble with 4? No? So what does negative on the inside do? It reflects across the y-axis. What does a negative 30 on the outside do? Down 30. What if we had plus 6 on the inside? Left 6. Okay. Right. If the negative's outside, then it would reflect across the x-axis. Yep. Okay. Number 5, 1 over x plus 1. We want the domain of f inverse of x. Okay, lots of things going on here. The domain of the inverse is always equal to the range of the original. So the domain of f is always equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So if we can figure out the range of this, then we don't have to take the inverse. So this has a domain restriction. Where is it? X can't be negative 1. Okay. The only thing that's going to restrict the range is a horizontal asymptote. Does this have a horizontal asymptote? Is the bottom bigger than the top? Yes, when the bottom is bigger than the top, then the HA is at 0. So we know y is not allowed to be 0. And you could always graph it and see that that's the case. So what is the domain of the inverse? Everything but 0. So, yeah, so this graph looks like, if you graphed it, it would look like this. Are there any y values that don't get hit? Just y equals 0. So the range of f is everything except 0, which means the domain of f inverse is everything but 0. Now, what if you forget that? How do you take the inverse of y equals 1 over x plus 1? Switch the x's and the y's. So every y becomes an x, and every x becomes a y. Now I just need to solve. So I'm going to do y plus 1 and y plus 1. Those cancel. And I'm going to divide by x. And I get y plus 1 equals 1 over x. Subtract 1. So the inverse is y equals 1 over x minus 1. Does that function have any domain restrictions? Are there any x's I can't plug in? 0, which we already knew from the last way we solved it. Okay, number 6. How do you do G of F? You put the F answer into the G. So we're going to take -2, plug it into F, take that answer, plug it into G. Everybody understand that? Do you need to see it? So I want G of F of -2, and F is 1 over x, and G is x plus 2. So I'm going to put -2 in there, and I get 1 over -2. Then I take that answer and I stick it in there. -1 over 2 plus 2 is going to be 1.5, or 3/2. We good there? Let me back up. What if it said, oops. What if it said this? How do you find G of F of x? I put the F function inside the G function, and I get 1 over x plus 2. Now the cool thing is, if you want to know this at -2, you can just plug it in here. 1 over -2 plus 2 happens to be 3/2. So you can either put the functions together and then plug in -2, or you can put -2 into one and then the answer into the other. Okay. How do I know this has a slant asymptote? The top is bigger, but that's not it. The top is 1 bigger, right? What if the top is 2 degrees bigger? Then it's a parabola asymptote. What if the top is 3 degrees bigger? Then it's a cubic asymptote. So whenever the top is 1 exponent bigger, 1 degree bigger than the bottom, you have a slant. How do we find the equation of the slant? It's really easy, and you've forgotten how to do it. You do long division. Okay? So I put an x and a 4, and then I put this in here. So 4x squared. Pull out a 4, or pull out an x, I get 4x. 4x times 4 is 16x. Now what? So now I have a plus 0x. So this box and this box need to add to be 0. So negative 16x. Pull out an x. Now what? What? Who's talking? That's it. Why? Right. The rest is just going to be a remainder. So this would be negative 64, and this would be plus 64. So it's plus 64 over x plus 4. Okay? But we want the equation of the slanted asymptote. And that is just this without the remainder. So if you want a slant asymptote, just do the division, but stop when you get the constant. You don't need to go any further than that. Okay, let's see if my voice is going to make it through the rest of this test. All right. P equals A times x minus h squared plus k. And it says x has to be greater than or equal to 0. So what they're saying is the company starts right now, and you can't go into the past. We know that the maximum is at x equals 50 and p equals 1600. We also know that when x equals 10, then y equals 0. So what we have is a graph that looks, so it hits here at 10, 0, and then over here at 50, it has a maximum. So the graph looks like this. Okay. How did I know that it pointed down? It said maximum, so it had to point down. Okay. So this here is the vertex, and it's at 50, 1600. So that's h, k. In vertex form, the maximum or the minimum is h, k. So I'm going to plug this in here, and this, nope, that in there. And then I also know that when x equals 10, y equals 0. What's the only thing I don't know? A. So I need to calculate A. So 0 equals A times 10 minus 50 squared plus 1600. So 0 equals A times negative 40 squared plus 1600. Negative 40 squared is 1600. I'm going to subtract 1600 and then divide by 1600, and I get A equals negative 1. Now what do I do? I put negative in front of the A and put what back in? Everything? Not the X and the Y, but I do want to put the H and K in. So Y equals negative 1 times X minus 50 squared plus 1600. The other way to do it is to put 3 points in your calculator and run a quadratic regression, but then you have to complete the square. But it does work. Okay. Number 9. Nope, that's the answer. That's the equation. Yep, we leave it just like that. Can I multiply this in? No, because there's a squared. So you'd have to do the squared first and then multiply it in. But that would be the wrong equation. That would be the standard form equation. We want the vertex equation. All right. And I know that x plus 3 is a factor. What does x plus 3 is a factor mean? It goes into it evenly when you divide it. It also means that what is a root? Negative 3 is a root. But I want to know the other factors. Okay, so how do I figure out the equation without that as a factor? Do division. Can I use synthetic division in this case? Yes. So what goes in the corner? Negative 3. And what are my coefficients? 0. Everybody see why I need a 0? Okay, drop the 1. Negative 3. 9. Negative 4. 12, and 0. I knew that was going to happen. If I got something other than a 0, I knew that I was going to make a mistake because it was a factor. Okay, now what do I do? Well, I have x squared minus 3x minus 4. Does that factor into x minus 4 and x plus 1? Which of the following is also a 0, -1, and +4? So the answer is C. Okay. X equals -1, mult 2. What does multiplicity 2 mean? It means that -1 is a bounce. It happens twice, right? So if I put -1 into the function 1, 2, 5, 8, and 4, I should get remainder 0. I did. Now what do I do? Do it again, because it's multiplicity 2. So I'm going to put -1 back in, and I should get remainder 0. Okay. Now what? Now I have x squared plus 4. What are the factors of x squared plus 4? Right. X minus 2i and x plus 2i. So true or false, 2i is also a 0 of f of x. True. Well, because we're just doing a shortcut. So x squared plus 4 equals 0. We're subtracting 4. X squared equals -4. So I get plus or minus the square root of -4, which is plus or minus 2i. Right, right. And what we've just memorized it. If it's x squared minus 4, it's plus or minus 2. But x squared plus 4 is plus or minus 2i. Okay. 12. So e to the 2x minus 3e to the x equals 0. What should we do here? U substitution. So is this one twice as big as this one? Did I skip one? Oh, I'll go back to 11 in a second. Sorry. This is number 12. So yes, so u equals e to the 2x. And I get u squared minus 3u equals 0. How do we factor that? Pull out a u. Oh, thank you. Sorry. Yep, u equals e to the x. Okay, so u times u minus 3 equals 0. So u equals 0, and u minus 3 equals 0, which is u equals 3. Wow. How did that happen? All right. So let's plug this back in. E to the x equals 0. E is a positive number. What exponent can you put on a positive number so that that number equals 0? E to the 0 is 1. And the answer is nothing. E to the x has to be positive. It can't be negative, and it can't be 0. So there is no way for e to the x to equal 0. And if you tried to solve that, you would end up taking the ln of 0, and the ln of 0 doesn't exist. Okay? And then e to the x equals 3. What do we do here? ln both sides. Drop the x. X ln of e equals the ln of 3. But the ln of e is just 1. So x equals the ln of 3. Do I need to plug this back in? No. If your original equation has variables under a square root or inside a logarithm, then you have to plug them back in. But the original equation here did not have logarithms, so we don't need to worry about it. All right, back to number 11. A third degree polynomial function has x equals 3i as one of its zeros. Consider the following statement. F of x has no real zeros. Well, what do I know about f of x? So I know that x equals 3i is a root. What else do I know? It's right. This is a third degree. That's important. And if 3i is a root, then negative 3i is also a root. Okay. Now what? There's one more root. What is it? It has to be real. Can the other root have an I in it? No, why not? I has to come with a partner. Every imaginary root has a conjugate counterpart. So if you have 1, you have 2. If you have 3, you have 4. There's no way to build an x to the third equation using real numbers that has 3 imaginary roots. So the answer is false. The third root has to be real. We don't know where it hits the x-axis, but we know that it does. Right? And another way to look at it is, if I had an x to the fourth equation, is it possible to build that so it misses the x-axis? Yes. All I have to do is lift it up far enough. But if I have this, is there any way to build that so it misses the x-axis? No. No matter how far I go down, I will always hit the x-axis somewhere. And no matter how far I go up, I will always hit the x-axis. So odd degree polynomials always hit the x-axis somewhere. And the evens usually do, but sometimes they don't. Right? And remember, you don't need to hand these in. I'm just going to give you guys points for working on them. Okay. 13. The ln of 2x minus the ln of 2 equals 2. I'm going to put those together using the quotient rule. So the positives go on top. The ln of 2x goes on top, and 2 goes on bottom, equals 2. I'm going to go ahead and simplify that and say the ln of x equals 2. What do I do here? Change it to exponents. What is the base of the ln? E. So e squared equals x. E squared equals x. Now, do I need to plug this back in and see if it creates any problems? Yes, because the original function had a logarithm in it. So e squared is a positive number. As long as I don't take the ln of 0 or negative, I'm okay. If I plug that in there, am I okay? Yes? What about the next one? There's nowhere to plug it in. The ln of 2 exists, so we're fine. The answer is e squared. Okay. like on the next one, number 14. So we have log of x plus 1 equals the log of x squared plus 1. So I'm going to use the product rule. They're both positive. So I get the log of x times x plus 1 equal to the log of x squared plus 1. Now what do I do? I could subtract it over. Oh, I see. So you're saying distribute this to be x squared plus x. Okay, that's fine. Right, now I have logarithm equals logarithm. So the log of some value is equal to the log of some value. So those two values must be the same. So I just drop the logarithms. As long as the logarithms have the same base, and you have 1 on each side, you can do that. And I'm left with x squared plus x equals x squared plus 1. Can you guys just look at that and see what the answer is? It's got to be 1, because these just cancel. So x equals 1. Do I need to plug that back in and check for zeros and negatives? Yes, because the original problem had logarithms. Am I okay plugging a 1 in there? Yes. Am I okay plugging a 1 in there? Yes. Am I okay plugging a 1 in there? Yes. So we're good. All right. 2 over e to the x minus 4 equals 2. I'm going to cross multiply. 2 e to the x minus 8 is equal to 2. So subtract 8, or sorry, add 8 is 10. Divide by 2 is 5. E to the x equals 5. So ln both sides, drop the x. And x, the ln of e is just 1. So the answer is the ln of 5. Which is B. I'm going to make it. I'm going to make it. What time do we get out of here? Okay, we're good. All right, partial fractions. 4x over x minus 3 squared. How many partial fractions will this have? 2. It has one factor, x minus 3, and that factor has a multiplicity of 2, so we also have to do that multiplicity. So a over x minus 3, and then the other one will be x minus 3 squared. Do I need a bx plus c on that one? No. So I just need a b. This one needs an x minus 3, so I get ax minus 3a plus b equals 4x plus 0. So I'm going to pull out my constants. Negative 3a plus b equals 0. And then pull out the x's, and I get a equals 4. I could plug that into my matrix, but I don't need to, because I know a is 4. And then how do I figure out the other one? Just plug 4 in there. That's negative 12 plus b is 0, so b must be 12. And the problem says, what is the numerator of the x minus 3 term? A, which is 4. Okay. I'm going to use elimination here, and I get 7x. Nope. I'm going to add those together. So I get x squared plus 6x plus 0 equals negative 5. Add the 5. So that's x plus 5 and x plus 1. So negative 5 and negative 1 are both x's. Now I need to find the y values. So let's plug those in to the top equation. So I get negative 5 squared minus, no, let's plug them into the bottom one. It's positive. So this is negative 30. So I'm going to add 30. Oh, the two values for x. Oh, we're done. We don't need to do the y's because I didn't read the equation. Okay. So if I had the matrix 1, 1, 0, 0, 1, 1, and I wanted to multiply it by the matrix 0, 1, 1, 0, 1, 1. So we'll call this A and this B. Is A times B equal to B times A? No, it's not the case. And you can see that. Can I multiply a 2 by 3? Oh my gosh, sorry. 2 by 3 times a 3 by 2. Yes, my answer will be a 2 by 2. What if I flipped them? 3 by 2 times 2 by 3. Can I do that? Yes, but the answer is a 3 by 3. So how do we multiply these? So you take the second one and lift it up, and then you build a 2 by 2 box to do the multiplication. And if I flipped them, then I would need a 3 by 3 box to make it work. Okay. So you would do this times this plus this times this. And then the answer goes here. And then for this square, we do this times that plus this times that. And then the answer goes there. Yep. So to do this one, you would take this row, because it lines up there, and this column. All right. That's it for the multiple choice.